So I'm going to be talking about a challenge that I see in contemporary uses of AI ethics, and the challenges we have and we're facing in this new emerging AI society. And I'm going to try to give three methodological rules which we can use to think about AI systems that take us away from the trap of ethics. And this is weird, and it goes against the grain to say that ethics is a problem, but in this case, I think we are heading in the wrong direction when it comes to how to produce sustainable AI systems. So today we're having morning coffee, of course. I hope you have it, and we're also swamped with different kinds of news about how AI systems is creating an unjust and unfair society. We've all seen news in different places about different things. For example, the thing you see now is that Amazon used an AI to speed up their recruitment process. Amazon gets tons of CVs, and they wanted to use an AI system to put certain CVs in the goods pile and certain CVs in the bad pile. And they wanted the AI to learn which CVs should go in the good pile from their own hiring practices, because that's what you do with AI. You give them a data set, you give them something from the real world, and you train the AI to do the same thing that it sees in the data set, or how to classify that data set. So Amazon gave the AI their hiring decisions, and the AI started discriminating against women, against female engineers. And they were flabbergasted, and they said, wow, why is this? It should be, helping us to hire, not to discriminate against women. And the problem is, of course, that society, that is Amazon's hiring decisions, were sexist from the start. So the AI became a sexist asshole to start with, just because Amazon did that. And we can see other examples where in the US, they use proprietary algorithms to risk assess criminals. And when you analyze them, there was a famous case in the magazine ProPublica, where they audited the algorithm that gave risk scores, and it was biased against Black people. And further, Twitter, Microsoft recently released a Twitter chatbot that was to learn to become a human on Twitter. Of course, it became a racist asshole in less than a day. And we can go also to Sweden, where we have this fear of automation and fear of the computer that will create an unjust society. So, for example, in the social services, there has been a strong push recently towards automation of economical assistance to people, socialbidrag. And this has led to very polarized debate. The municipality in the southern Sweden that has gone the furthest are very proud. They get lots of praise for what they're doing, while other municipalities have huge fights about this automation. And the argument from the social secretaries is that, well, I mean, sure, it's all good that we automate, that people get their economic assistance, but it's when we meet people for giving them economic systems that we discover the other problems. So you had 12 out of 16 social secretaries in Kungsbacka quitting out of fear of automation. We also use AI to predict crime, to send police to certain areas before crime happens, to predict hotspots for crime. If you've ever seen the Tom Cruise movie, I forget the name. It's called Minority Report. If you ever see the Tom Cruise movie Minority Report, which is a sci-fi movie, you have a state where the police act on predictions of the future and people get arrested before they've committed crimes. This is not going as far, but it's really difficult to validate if the system works, right? So you have a system that sends police to an area before a crime has been committed. And if a crime is not committed, the argument has often been that the system worked because the police being there stopped the crime. While if the police come there and there is a crime, then of course you can say the system worked because it predicted a crime. So it's difficult to validate systems in the real world as well. Also in Sweden, we have research going on. German Bender at the Stockholm School of Economics is looking at algorithmic control of working life. And of course, we can think about call centers or Amazon warehouses where algorithms score and rank you and so on. So of course, yes, we are definitely entering into an arena of algorithmic control and AI. And the fear, of course, is that we become oppressed by the algorithm, that we automate inequality, that we institute weapons of mass destruction, that we have racist algorithms that oppress the poor, and so on and so forth. And the common, thread to counter this is that we need algorithms and AI systems that are fair, accountable, and transparent. So in a sense, this is the perfect marriage between philosophy and computer science, because philosophers often attempt to understand the worlds through ideal typical answers or questions. So they invent a situation where they remove all types of confounding variables, and then they try to decide what is fair. And of course, that works perfectly with computer science, which needs to reduce society to a mathematical formula. And then, of course, if we have ethicists that say how that formula should calculate, that, of course, would lead to fairness in their view. So, I mean, the strongest push today in AI ethics is, trying to find the algorithms or formulas for fairness. And the acronym for this is FAT, fair, accurate, transparent. And as a sociologist of science and technology and using anthropological methods to study technologies in organizations and in science, this is very problematic. And I will explain why, and I'm going to try to also explain what we can do about it. So what is my problem with machine ethics? Well, first of all, is fairness really mathematically possible? Is it possible to have an ethical system which is premised on a mathematics that is also fair? And David Sumpter, a mathematician from Uppsala University, has analyzed this risk prediction system that I was talking about earlier. And he argues that, no, we cannot outsource fairness to an algorithm. It doesn't work mathematically. So if you have two groups of people that you're trying to work with statistically and mathematically, for example, Black people and white people, if you want one group to be treated fairly, that the other group will be treated unfairly. So mathematically, I'm not a mathematician, so I'll take David Sumpter's word for it, and I've talked to other mathematicians about it, and they agree. So if we want to create an ethics of computer science, we cannot turn to the algorithm for the answer. So the other problem is that can we really make computer systems accountable? And here I wanted to draw on an example from a colleague's research in St. Andrews. He studied heart transplantation algorithms or organ transplantation algorithms. In the UK, organs for transplantation are handled with an algorithm. Who gets a kidney or who gets a liver is decided by a mathematical and algorithmic calculation. And of course, people in the healthcare system in the UK, they love this algorithm. They think this is the greatest thing since sliced bread, because who wants to make life and death decisions? Who gets heart? Who gets an organ? It's a nerve-wracking and a very sad decision to make. So the people who work in the healthcare system think this is lovely. It also solves problems of resource allocation, where previously local hospitals or local hospital regions were decided who got an organ. So, and then you all of course get into the question of who is worthy if you need to make a decision locally and you know the people. So the algorithm was very, very welcome. But then Philip Roscoe also has looked at the fairness, mathematics of fairness in the algorithm. And one of the things that the algorithm does, I'm sorry, I just have to let out the dog here. Sorry for that interruption. Anyway, so he studied the mathematics of an algorithm and analyzed how the algorithm allocates organs. And he's found that old people get higher scores. Old people get higher scores. This is the place where everybody pauses in the audience. I can't see if you're pausing, but I'm guessing you are and thinking, wait, he misspoke. No, I did not misspeak. So old people get lower scores, higher scores, because the person who made the algorithm thought that young people were irresponsible. They did not take their blocker medication. So you have an algorithm which has assumptions about people drawn up in certain ways. But so is this an ethical algorithm? And does it really solve the problems? And then you, of course, have the question of healthcare personnel being able to game the system. So the healthcare personnel, they actually learn to game the system and say, well, we have a particular deserving patient here who has 2 kids, is single, is really struggling, and has been really good at managing the disease and taking the medications, and they actually bump up the scores for that patient. They game the algorithm. They learn how it works. So even though we have then a system where the computer supposedly is supposed to take a decision, we always have people working around the system and trying to game the system to get what they want. So as long as we have humans in society, it's going to be difficult to assign accountability in terms of algorithms. Who is accountable then? Is it the algorithm? Is it the doctor who made the algorithm? Is it the hospital personnel that that is gaming the algorithm. And that's, of course, what happens in organizations everywhere around rules and regulations and so on. And can we make these algorithmic systems transparent? And of course, here you see an image of a computer tangle. These are all network cables in a computer system, but that represents really not just the mess of computer cables, but the mess and complexity of computer systems. So I've studied how Zika and diseases are predicted at the European Center for Disease Control and Prevention. And I've looked at how they work with data and how they try to predict the risk of spread of disease for using computer systems. And the interesting things, of course, is that AI systems and algorithmic systems are extremely data hungry. They need lots of data to work. And this is where things start to become complex. So in the Zika case, they need to predict where there is a particular type of mosquito, an Aedes aegypti mosquito. It's prevalent in Africa and South America, and it's starting to move into the southern US and into particular places in Southern Europe. So how do you then track the risk of spread of disease through a mosquito? Well, the people at the ECDC, they draw on lots of interesting computation resources. They use satellite images. They use for climate data to understand how the climate looks globally. They take data from that's published on where this mosquito, the Aedes aegypti, exists in the world, which is published in the scientific literature. And of course, that literature goes back to the 60s and forward to today. So, and they also take data from the US CDC. They take data from different climate models. They take data from a climate map that was made in the 1800s for the first time. So the data that's used to predict the risk and spread of disease is not only a prediction of here and now, it's a prediction where the computer system spreads out into time and space. And this is often the case with computer systems. They spread out in time and space, and the data they use spread out in time and space. So to look at the transparencies of that computer systems at the ECDC, we can quickly see that, of course, at the ECDC, in Stockholm, where it lies, there are particular knowledges about viruses and Zika and mosquitoes that are available and transparent for the people in the organization. And they can muck about with algorithm in those cases to predict, change the prediction and change how things are thought about and so on. But the modeling of the risk of transmission is done at Oxford University with a group of entomologists, people who work with entomology, that draw on all these data sets. So where is a computer system? Where is the data? How can we make that transparent, that mess? And it's a chimera to be able to boil down ethics into a mathematical formula and say, well, this is a fair system, because it's impossible to be able to make all of the parts of the system transparent. And so AI ethics tries to look at this type of computation, this algorithm. Is this algorithm fair? The decisions we make mathematically in the computer. And with my argument here, and I'm going to give three methodological rules for how we can do that, is that we have to leave behind this idea about ethics, and we need to start looking at the mess the organizational mess that surrounds the computer system. Of course, if we think about German Bender's research into the workplace, that becomes obvious. If we have a call center where the algorithm calculates the performance, everything is algorithmically controlled. You have a scoreboard in the room where you see how fast you call and how many calls you're taking and doing and how much money you're making for the company. I mean, it's very easy to point to the algorithm and say, you're underperforming according to the algorithm, right? Same goes for Amazon warehouses and so on. But that's where, you know, the idea that we should audit the algorithm goes very wrong, because that's really much a case of saying the computer says no, you know, from the sketch. We need to look at the mess that surrounds that algorithm. We need to look at how were the parameters set, who in which rooms were they set, how can people get involved with the parameters that are set in the algorithm, how do we produce processes and organizational structures and so on that support creating systems that work in situations. So if we simplify, you know, this idea about algorithmic ethics, I think we can perhaps see 3 different strategies that we can use as researchers to understand algorithms and AI in society. So now I've been talking about AI ethics, which is an ethics of going under the hood. I mean, looking at the mathematical calculations in the computer and the reduction of society and social relations and power relations to what I call machine ethics. And here you see, of course, the paradigmatic example of machine ethics. It's the trolley problem with a self-driving car. What should the car do in this situation? Should it hit the car, the cat, or run off the cliff? And this is, of course, the favorite pastime that I was talking about, that ethicists and computer scientists like, because it clarifies everything, it removes all the mess and says, what if this happens? But of course, it's never that easy. A decision is always entangled in different types of politics and different types of decision. A friend of mine, he asked me recently, if you were in a hot air balloon with 8 other people, and you had to decide who's gonna, the balloon is losing height and is gonna crash into the ocean. And he asks me, who should you throw out? And how do you decide that? And he's like, and if somebody volunteered, if somebody volunteers to jump out, and he says, well, we can't decide it like that, because that's against altruism. We need to have that altruistic person with us at all times, because we need to keep that person. We can't throw that one out. And then I start asking questions, but who is this guy? Does he have an end-stage cancer? Is she depressed, terminally ill, and so on? But that's beside the ethical thought experiment, which is, of course, why AI ethics also is problematic. We can't remove all that mess. Another analytical perspective, which goes really along with the backbone kind of movements in social science, is to look at the negotiations. We look at the work practices. We look at how people experience things. We talk with people about how they negotiate it. Well, should we follow the algorithm or not? Is the algorithm correct? And so on. And I have a good friend, Malta Zievitz, who does in Cornell University, who's done an algorithmic walk through Oxford, where he was doing his PhD. And he wanted to see how people negotiate around algorithms. So they constructed an algorithm to say where they should start, where they should walk, how they should decide in each intersection, and so on. So they started walking, and they started going left and right and looking at the algorithm and says, all right, we're supposed to take right here. And then they come to edge cases, like, is this taking a right really? Or does this work algorithm? How does this algorithm work in this case? So they need to start, messing about with the algorithm. And Malte starts thinking, my dear friend, he starts thinking, oh no, not this street again. I've shown this a million times to everybody who visits Oxford. He starts to game it. So there's this possibility of looking at how people handle and work with algorithms in practice. But my favorite way of analyzing algorithms is actually looking at them as the movement of power. The power to decide and the power to understand. If you think about my complicated case with the Zeek algorithm, where Oxford, Stockholm, data from the 60s, data from today, data from the US CDC, you can see that there's lots of different places in where you can make choices. And this, I think, is where we can make the best types of analysis of AI systems, looking at where choices are made, how choices are moved around with AI systems. And this really points towards organizational research, and it points to ethnographic methods to look at how algorithms work in practice, but also how they connect other places and times to see where decisions are made. So the point of departure, I think, then, for a good AI analysis is that fairness, accountability, and transparency happens in a social, organizational, and human context. There's no mathematical formula for fairness. And of course, what is fair for some people might be unfair to others. So how do we do this? How do we do these points, these analysis? And I have 3 methodological rules that I think we should all be mindful of when we try to help organizations, public bodies, private companies to build better AI. And of course, then my argument is in the title of the talk also. We don't focus on the machine ethics, not of the mathematical computation of fairness. So the first rule is don't punctualize agency. And this means it's very easy for us in society to assign blame to an algorithm or a thing or a place in the world, a point in the world. Think about Little Britain and Computer Says No. And we can see that both computer scientists, ethicists and philosophers, and sociologists and ethnographers or organization studies people again and again fall into the trap of reducing complex relations in society and organizations to the algorithm. So rather than focusing on that point in space and time, trace how algorithmic action happens at different places and times. And this is more difficult than prying open an algorithm and studying it. You have to go walk around an organization or a place, and you have to look at how the system works. But you also have to pry into the system and look what other places does the system take me. So this is not the easy way out, but I think it's the more powerful way to build justice into computer systems. And the second rule then is that we need to abandon this idea about the opaque or dangerous algorithm. You saw there's a famous book called The Black Box Society, which argues that we're all becoming part of a society where we have no insight into how decisions are made. And on the other hand, we have the ethicists and the computer scientists saying, well, we need transparency of these systems. So we have this binary idea, a duality of transparency on the other hand, which is the solution to darkness and opacity on the other hand, where we can't understand the algorithm. And of course, the transparency of a complex AI system is an impossibility. Think about the Zika map. We draw things from everywhere. And where is then transparency? Well, transparency shifts in and out of view. It's situated in particular situations. If you, the people at the ECDC in Stockholm make a call to Oxford, of course, they can understand things better. And if it's not possible to make a call or question things, then of course that moves transparency away. So rather than looking at this binary pair, look at translucency, situated translucencies. Look at how things happen in particular times and places. And then the last rule then, look at power. Where in the fabric of action, in that mess and that jungle of cables and computer systems and data systems, where do we have the power to make the choice? What sites, what places in the world, and what offices, what rooms become dominant? Where, when, and where can choices be made? Who can make the choices? Who understands them? And where are they? And so this is the conclusion, I guess, of my talk. So my argument is that we need more organizational, ethnographic, and social science research to have a fair and ethical AI society. We can't rely on auditing the algorithm or having ethicists look at the algorithm for fairness. We have to look at the power relations. We have to look at where we can make choices, how transparency is assembled in practice, and where power clusters.